Hey everybody. Today we're going to work with really a whole bunch of ideas: Pythagorean theorem, SOHCAHTOA, the coordinate plane, reducing fractions. So what's going to happen is we're going to move these triangles to anywhere in the entire XY coordinate plane. So signs will change. We can have things positive, negative. We'll also talk about what happens when they land right on the X or Y axis. So because this is a right triangle, I'm over here. We went left or right, that's X, and then you go up or down, which is Y. So we have a right triangle with X, Y, and R, so we can use Pythagorean theorem. X squared plus Y squared equals R squared. Now, as you know, X and Y can be interchangeable because those are the legs, but it has to equal your hypotenuse squared. So now we're going to have different names. So rather than calling the sine opposite over hypotenuse, if this is our angle right here, the opposite side is Y, and the hypotenuse is R. This will allow us to apply it to anything. So we can just use the X and Y, and we don't necessarily need to know the hypotenuse or the opposite side. So for the cosine, instead of being adjacent over hypotenuse, this will be X over R. And of course, tangent, instead of opposite over adjacent, this will now be Y over X. Now, for these, the reciprocals, it's always probably faster if you do the sine and then do the cosecant right afterward, because all you have to do is flip it over. And then, of course, secant goes with cosine, so that'll be R over X, and cotangent is the reciprocal of tangent, so that's X over Y. So we're going to graph this point, and then we're going to find the exact trig functions, which is, they gave us a little list down here. So when we plot this point, we have to pay attention to its location, the signs, everything. So we go right 9, and we go down 12. So here's your right triangle. We always make the right triangle to the x-axis, and of course this is our missing side. So we have Pythagorean theorem, 9 squared, negative 12 squared is positive, and of course we're missing the hypotenuse. So this is 225, which is a perfect square. Now your hypotenuse will always be positive, so you don't have to worry about its sign. It's the X or the Y that might be negative. Now we do know that the 12 is negative. So for the sine, remember this is the angle, so the sine is the Y value. So we have 9 negative 12. This is X, this is Y, and we know R is 15. So those are the numbers we're using. So this will be negative 12 over 15. All fractions have to be reduced. So this is negative 4/5. Cosecant, negative 5/4. So we'll just flip it over. For the cosine uses X, so 9 over the hypotenuse. They're both positive. We've got to reduce that. And then, of course, flip it over for the secant. And for the tangent, we're going to do Y over X, so negative 12 over 9. Which reduces to negative 4/3, and then we flip it over for the cotangent. Let's just do one more of these, because what are you going to do if you have a radical? How do you fix that? So again, let's graph this. So we go this way, 6, and then down 2. So they're both negative. And then we need the Pythagorean theorem to find R. Negative 6 squared, negative 2 squared, and we're looking for the hypotenuse. Now 40 is not a perfect square. It is 4 times 10. So it looks like it's 2 radical 10. And it is always positive on your hypotenuse, no matter where it lands. So for the sine, we have negative 2, because that's your Y, over the hypotenuse. These reduce, but then we have a radical in the bottom, so we have to rationalize. So we get negative radical 10 over a plane 10. Now when you go to flip this over, I wouldn't flip this one over, because the radical is going to end up on the bottom. I'd flip this one over So if we think about these being gone, we just flip this over. That puts the negative radical 10 on top and the 1 on the bottom. You can flip over anything you want to. I'd flip over the one that doesn't need to be reduced. For the cosine, we're going to have negative 6 over 2 radical 10, which again, this reduces. So right here, if it's easier, we can flip this one over very, very easy. This is negative radical 10 over 3. So you can see maybe a little bit easier now, but we got to rationalize this because this cannot have a radical in the bottom. So we get negative 3 radical 10 over 10. And for the tangent, it's negative 2 over negative 6, which is positive 1/3, reciprocal 3 over 1. Now to help remember the trig functions and where they're positive and negative, we have this little statement right here. All students take calculus. And it goes in order of how we number the coordinates. So this is, it goes like the letter C. Ooh, not sure what that is. Sorry. So it goes like the letter C. So we start here. This is quadrant 1. This is quadrant 2, 3, 4. So it goes all, and then S for students, T for take, and C for calculus. Now what that also stands for is sine, cosine, and tangent. So this is where the sine is positive, this is where the tangent is positive, and this is where the cosine is positive. We don't really care about the reciprocal functions, they just kind of go along with the functions themselves. So in quadrant 1, all things are positive. In quadrant 2, the sine is positive. In quadrant 3, this is where the tangent is positive. And in quadrant 4, this is where the cosine is positive. So now we're going to use this little information to sort of figure out the answers to these questions. If the cosine is greater than 0, that's a fancy way of saying positive. Where could the angle be? All right, so if the cosine is positive, it's not here or here, so it looks like it's quadrants 1 or 4. If the tangent is negative, all students take calculus. So the tangent is negative here. Oops. So the tangent is positive here and here if we do it that way. So the tangent is negative in these two quadrants, which is quadrants 2 and 4. Now secant. Secant goes with cosine. So we think of it as cosine. So if the cosine is negative, well, a cosine is positive here and here. So the cosine is negative here and here, so that's quadrants 2 and 3. Now here we have two things going on. Sine is negative, and cotangent, which we'll think of as tangent, is positive. So sine is negative. Well, sine's positive here, sine's positive here. So we're looking in these two quadrants. And cosine is negative there, so or cosine's positive there, so that's where the tangent's negative. So it has to be in this quadrant right here. So it can only be in quadrant 3. So now instead of starting with a location, they're going to actually give us a trig function to find the rest. Same rules apply. We have to pay attention to the signs, the plus or minus signs. Sine is opposite over hypotenuse. Let's figure out where the location is first. So the sine is obviously a positive number, so that's here or here. And the tangent, they're saying the tangent is negative. Well, the tangent's positive here, so it must be in quadrant 2. So let's draw that, which makes sense. The sine is positive. So we went over here. So this is opposite over hypotenuse. So the negative one is what we're missing. So we'll use Pythagorean theorem to find that. So 64 plus I'll call it x squared equals 17 squared, which is 289. So x squared equals 225, which is a perfect square. But remember, it's negative because look at the direction in which we went. So the cosine is negative 15 over 17, which I'm going to go right ahead and do the secant, just because it's easier to do it that way, I think. Tangent is negative 8. It's actually 8 over negative 15. We generally put the negative on the top, which means the cotangent is negative 15 over 8. And the cosecant goes with the sine, so that was 17 over 8. So let's take a look at this one. Cotangent. Well, I don't know cotangent, but I know tangent's opposite over adjacent. So cotangent is adjacent over opposite. I had to figure out what quadrant it's in, though. So the cotangent is negative. Well, that's positive here and positive here. So we know all students take calculus. So the secant is positive. Well, secant goes with cosine. So cosine's positive right here. So must be fourth quadrant. So the cotangent is negative 4 over 1. I don't really know. You have to make sense out of the picture to figure out which one's negative, because clearly this is a positive 4, but we went down 1, so it's a negative 1. So we're missing the hypotenuse. So 16 plus 1 equals the hypotenuse squared. So 17, and so square root of 17. So let's put this together. So sine is, this is our angle, so sine is negative 1 over radical 17. Well, we got to fix that. So we get negative radical 17 over 17. Sine goes with cosecant, so I'm going to flip over this one. So it's just negative radical 17. We know that the cotangent was negative 4, so the tangent's negative 1/4. And now it looks like we just have cosine to do. So cosine is going to be 4 over radical 17. So this is radical 17 over 4. And we have to fix this. So we get 4 radical 17 over 17. So the trick is to make sense out of the picture for your positive or negative, and also just to do the reciprocal function right away so you don't have to think about it. Now, reference angles. We draw a reference angle. It's a positive angle, and it's also an acute angle. So when we do this, our answers will be positive and acute. Also, we draw it to the x-axis. This is all super important because being able to do this correctly is the first step in many, many, many problems that we'll be doing. So when we think about starting at 0 degrees, this is where 0 is, and we rotate around this way, if you remember, for positive angles. Negative angles, we start at 0 and we spin down and go this way. So we've done the rotating before. Now we're going to figure out the reference angle, or the space between your angle and the x-axis. So this is the axis that we're focusing on right here. So if we think of 150 degrees, well, that's over here somewhere, right? Because this is 90 and this is 180. So it's definitely in that second quadrant. So we know it ends somewhere in here. It doesn't have to be perfect. So basically we want to figure out, well, how much space is there between, this is the 150 line and the 180 line. So we just subtract 180 minus 150, and we get 30 degrees. So the reference angle is 30 degrees, because this is where the triangle would go. So it says to find the reference angle, sketch the angle and find the reference angle. So 315. So we're going to go all the way around almost to 360. So it's right in through here. And so again, we would always compare this to the 360. So in this quadrant, we have to do 360 minus 315, because you want it to be a positive number. This is a 45-degree angle. Now, negative 240. So when we go negative, we just think of this as negative 180. So we're going to go past that. So now we're truly thinking, well, what's the space between 240 and 180, which is 60 degrees, right? Because this is the triangle that we're looking at. Now, radians are actually much easier. Basically, whatever the denominator is what the answer will be. So 5 pi over 3. If we draw radians, this is 3 pi over 3. We double that. That's 6 pi over 3 over here. So 5 pi over 3 is almost all the way around. Well, if we're at 5 pi over 3, we're only 1 pi over 3 away from making a full rotation. So it's pi over 3. That's what I was talking about. They match. So without really doing much, you know that this one's probably pi over 6. But let's draw it so we can figure out what it looks like. So this would be 6 pi over 6 because that's 1. And we're going to go with just one more. So we're right here. Here's our triangle. And so the space between 6 pi over 6 and 7 pi over 6 is pi over 6. Even though this is negative, we know the answer is pi over 4. So again, radians a little bit easier to think of when we have to subtract, which is helpful. So this is negative 4 pi over 4, which means we have to go one more. So there's where our angle is. There's our triangle, and the reference angle is always positive. So we know that it's positive pi over 4. Now this last little bit is just purely for information, but it's something that we'll use over and over again. The quadrantals. So quadrantals means that they land right on an axis. So 0, pi over 2, pi, and 3 pi over 2. These are all considered to be quadrantals. So when we say quadrantal, that's what they're talking about. They lands right on an axis. So 90, 180, 270, 0, and 360, whether it's positive or negative.